Hello everybody, am I audible to you guys? Please let me know. Hello everybody, am I audible to you guys? Please let me know. So I think I am audible to you and I'm waiting for your message, for your confirmation. Please check that your audio and video is clear to you or not. Right? Who is watching me live? Can you tell me? Can you give me the confirmation on the Telegram? Okay. So I hope guys that I am audible to you. Okay, so I think we should start our session. So as you know that guys, welcome again. Good evening to all of you, and it's our lecture number 11, and as you know that we are studying the classical thermodynamics, which is the first part of the thermodynamics, right? And in the last 10 lectures we have done you can say the basics, the basic terminologies, the basic foundation of this subject, plus we have started the 0th law and the first law, and now we are studying the different processes in the thermodynamics. I hope that every single information is crystal clear to you, right? With questions. But still, if you have any doubt, as you know that we are available on the Telegram group, right? So who is watching me live? Can you tell me guys? After that, we will start our lecture. So we will wait for others to join the class, and till then, let's discuss whatever we discussed in the last session, or you can say in the last part. So in the different processes, in the different thermodynamic processes, we have discussed already the isothermal process. So isothermal process is nothing but it is my constant temperature process, right? Isothermal, it is constant temperature process. It means temperature is not going to change. It doesn't mean that we are not giving heat to the system. No, it doesn't mean. It's nothing like that. We are giving the heat, but the rate of the heat transfer is equal to the rate of the work done. That energy is equal actually. That's why we can say that whatever energy we supplied, that total energy goes into the work done. So there is no internal energy change. So if the internal energy is constant throughout the process, it means that there is no change in the temperature, right? So this is what we already discussed about, right? After that, we have discussed about the slope of the PV. So first of all, we discussed about the PV diagram, right? And like the P is decreasing and the V is increasing. So first, we basically discussed the PV diagram, what kind of diagram we can expect from this graph, right? From this process. So this kind of graph we basically kind of hyperbolic graph we basically you can say we can expect, right? And after that, the very important, the slope of the PV graph. Directly question is asked on this slope. So very simple. If you are able to remember this formula, well and good, minus P by V. Otherwise, you know the PV relation for the isothermal process, that is PV is equal to constant, and from that equation you can derive the dP by dV by the differentiating the whole equation, right? There is no issue. Okay, so this is the important, PV is equal to constant, or for any two processes we can write P1 V1 is equal to P2 V2, right? So it is P1 V1 guys, it is P1 V1. please correct it. I don't know, I think जल्दबाजी में हमने इसको गलत लिख दिया. It is P1 V1 is equal to P2 V2, like this. P1 V1 is equal to P2 V2. Okay, means the product of the P and V will be the constant. Good evening Anushka, right? So we have discussed the slope of the PV graph. Hanji. After that we discussed about the work done of the isothermal process. So work done, we derived that W is equal to nRT ln V2 upon V1. Yeah, good evening Mohammed. So work done, we derived nRT ln V2 upon V1, or the nRT we will replace this nRT to the P1 V1, right? P1 V1. So P1 V1 ln V2 upon V1. If see, please pay attention to my words, what I'm saying, right? So everything we cannot write on the notes. There are certain things which is basically to be remembered. So here this is the initial condition. If I know the initial condition, or you can say the initial parameter of pressure and volume, right? And after that, if we know the next, you can see the final volume, then we can use this formula to find out the work done for the isothermal process. If we don't have the value of the pressures, then use this formula. If we have the, see, in the both the formulas, the volume information should be required. If only temperature is given to you, then use this formula, and if the initial pressure and volume information is given to you, use this formula. If in terms of, instead of volume, if the information are in the pressure terms, then use this formula. Okay. So work done is my positive guys, right? It is clear to you. If you will see here V2 is my greater than V1. So if ln terms is greater than 1, it means that ln give you the positive value. So that's why I can say that this is the positive work done, right? So this work done is for the expansion process, right? So in the expansion, we know that work is done by the system, right? It is clear to you. So if the work done is positive, it is means it is expansion and it is the work done by the system. It is work done by the system. If V2 is less than V1, then W is negative and it is compression. It is my work done on the system. Right? It is clear to you? Okay. So there is only need to put negative sign, that's it, nothing else, right? If we'll talk about the heat transfer guys, then as we know that the internal energy is not going to change. So these both the terms are equal. So mathematically the heat transfer and work done for the isothermal process is same. Only by mathematics, not by meaning. Okay. Yeah. If I plot the PT graph, then this kind of graph I will get, because temperature is going to, you can see the constant throughout the process. In the VT process also the temperature is going to constant throughout the process, right? So this is my PV graph and I am explaining the expansion process. In the expansion process, as you can see with the help of this arrow, that pressure is going to decrease. So in this process, pressure is going to decrease. In the expansion, volume is going to increase. So here you can see the volume is going to increase and my temperature will be constant throughout the process. I hope that till this thing you have, you can say there is no problem and you are basically done with this. Please give me confirmation. After that I'll start the next part, that is the comparison of between the isothermal and adiabatic process. Directly question is asked on this comparison. Please let me know. Please let me know. Okay. So guys, in the group, as you can see that there are a lot of students of EIiDelhi are in the under 20 ranks, right? In which there are rank 2, rank 5, right? Rank 6, rank 20, like that. So to share this information in your group is the purpose is only to motivate you. It is clear to you, and I hope that you are now so dedicatedly you will prepare for this exam, and I hope that you will you can say that you will now prepare, you can say mentally that yes, I can do also this, yes, I can also perform very well like this. So we will work hard for it, right? And we will convert this, okay? And all the EIiDelhi teams are with you. So just only we need the support. That is your only the hard work. That's it, nothing else, okay? Yeah, so comparison between the isothermal and adiabatic process. What is the basically comparison? Let's understand this. So in the adiabatic and in the isothermal process, we have discussed one thing, that is the slope of the graph. Okay, so let me write the isothermal process at the one side and adiabatic process at the other side. Okay. First of all, what is the base equation for the isothermal? That is PV is equal to constant. And this is my PV raised to power gamma is equal to constant. Okay, it is clear to you. First thing. Right. Secondly, the important parameter to define this difference is my slope of the PV diagram. Slope of the PV diagram. So if I will talk about the slope of the PV diagram, then it is my minus P by V, right? And if I will talk about the adiabatic process, then the slope will be gamma times minus P by V. Right? Or in the other terms, I can write this term, slope of the adiabatic process is nothing but it is the gamma times of the slope of the isothermal process. What is the meaning? Meaning is that the slope of the adiabatic process is, you can say, more as compared to the isothermal process. If I will give you the different PV diagrams for the isothermal and for the adiabatic, you will not, you can say, figure out that which graph is isothermal and which graph is of the adiabatic, because the more or less the pattern of the graph will be same. But if I will get the graph of isothermal and adiabatic in a single graph, then how I can figure out which graph is for the isothermal and which is for the adiabatic. So this is how, guys, we can figure it out. So I think that you guys already figure it out, that how we basically find out the graph. Okay, so let's suppose, guys, there is a graph we have for the PV. There is a PV diagram we have. Okay, this is my PV diagram. Okay, so I'm drawing this graph, and meanwhile, please tell me that what is this is my x-axis, this is my y-axis. Can you tell me that which line has zero slope and which line has the infinite slope, please? Meanwhile, I'll try to plot the graph. Please tell me. this is any point here, the wall here, the pressure is my P and y-axis is my B. X-axis zero slope, okay, very good. Okay, so yes, x-axis has a zero slope and the y-axis has the infinite slope. How we define the slope? Mathematically it is very simple to define this. Like, what is my slope? Slope is nothing but it is the you can say the change in the y and divided by change in the x. This is my slope mathematically, right? So this line, x-axis line has, there is no change in the y. So change in the y is 0, or you can say at the x-axis. Yes, I'm repeating, Mohammed. X-axis, if I want to find out the slope of the x-axis, so at the x-axis, the value of the y at every point is 0. At every point, the value of the y is 0. At every point at the x-axis, the value of the y will be 0. Right? If I want to calculate the slope, then y will be 0 here. So the slope will be 0. Slope will be 0 for the x-axis. And if I talk about the slope of the y-axis, in that case, what is the case? So at the y-axis, at every point x will be 0. So if it is 0, then it is my infinite. So this latitude line has a 0 slope and this longitudinal line has an infinite slope. And in between these, all the lines had something, all the lines have some slope, right? It is clear to you. So how to figure out the more slope? It is very easy. See, it is very easy. Like this line and this line. So line 1 has less slope or more slope as compared to 2. So 2 line is basically inclined towards y-axis more than the 1. So it is very simple to figure out that the line 2 has a higher slope as compared to the 1. It is clear to you? So if I'll see that this line is having the higher slope, this line has the higher slope, right? And we know that the adiabatic process has the slope larger as compared to the isothermal gamma times. So adiabatic process slope is greater as compared to the isothermal, and this line is for the isothermal process. So it is very simple, guys. It is very simple. Okay, it is clear to you or not? You will find a GATE question based on it, so you can solve that question. This comparison is important. If you will allow, then I can move forward. Yes. Okay, great. Yeah, Anushka, is there any problem, beta? This is clear to you or not? This is clear to you or not? Guys, we basically dig down the deep layer of the thermodynamics, right? I discussed each and everything in limited time, in which we have discussed each and everything from basic to the advanced. Also, we have discussed the very good quality of questions, right? And if you have need any kind of you can say that if you want to see that, yeah, we are solving this question, these are the very good questions or not, then compare these questions to the previous year questions. We will find that these are the previous year questions, but we have solved you can say the very difficult questions. So if we will solve the difficult questions, or if we solve the conceptual questions, good questions, quality questions, then we can solve the average question in the exam, because there is so much pressure, you can say, in the examination hall. Okay, right? And I think Anushka is basically our previous student, and we have covered so much subject. I covered so much subject in the, you can say, the last year students, and I think Anushka is a witness of that. that हमने जो नॉर्मली ऐसे लिखा कि ये मार्क कर लो, ये चीजें हैं, ये आप इसको बार बार रिवाइज करो, डायरेक्टली वो क्वेश्चंस गेट में आए हैं डायरेक्टली. If I emphasize on something or very much and I am giving my statement that this is important, there are high chance that the question is basically can be based on it in the upcoming GATE examination, and it's there, right? So basically just my main motto to say this is, whatever I will say that this is the important, guys, you can say take it seriously. If I will say that the question from this concept may ask, means there are high chance that question will be asked on that topic. So where can I get the EiiDelhi PYQs? Yeah, Muhammad, talk to the management for this. If you have the number of, you can say, any management person, please call to them for the book and all, for the material, or else I will talk for you. Okay, I'll pass your message to the management, to the concerned person. Okay, right. Okay, so I hope that this is clear to you. Now, temperature estimation using the PV isotherm. These are called isotherm, guys, right? These are called isotherm. Isotherm means that the temperature is, there's a PV diagrams for the isothermal process. These diagrams are called isotherm. Okay, for the adiabatic process, PV diagram is called isotherm. Okay, so this is not any, you can say, the different term. Okay, so I'm now with the help of the isotherm, I can estimate the temperature, means which temperature is higher or which temperature is lower. This is what we will try to calculate. That's it. Okay, so please first let me plot a diagram. Let me plot isotherm. After that you can plot the diagram, because in between I will make some mistake while drawing. Okay, so this is my PV diagram, right? And let's suppose I have isotherm, this, right? So these isotherms are at the different temperature. Let's suppose this isotherm is basically, I am plotting at the temperature T1, at the temperature T2, at the temperature T3, and at the temperature T4, right? So this is for T1 temperature, this is T2, this is T3, and this is T4. And I want to know which temperature is higher as compared to the other, right? So I want to know T1 is greater than T2 is greater than T3 is greater than T4, or T4 is greater than, right? So I'm saying this is true by seeing this graph, or this is true. This is what we will try to figure out. Okay, so for this, a very simple thought process would be, let's suppose I am going from this to this. Okay, I'm going, let's suppose it is my A and this is my B. I'm going from this to this, right? See, what is the PV relation for the isothermal? It is my PV is equal to nRT, and I know that T is my constant, so PV is equal to constant. PV is equal to constant. So this quantity is my constant, let's suppose. Okay. So for sure, just if my P and V product will increase, then my T will increase. I hope that mathematically we can say so. If my PV product will increase, then T will increase. This is for sure. So if I'll calculate the P at the point A and the V at the point A, then this is the amount of V. Let's suppose it is my V1, and let's suppose it is my P1. Okay, at this point you can see that my volume will increase, but also my P will also increase. At this point you can see that my volume will increase and my pressure will also increase. And at the point B, as you can see, that volume further increase and the P also further increase. It means the P4 is greatest value as compared to all the P. V4 is also greater value. It means P4 V4 is the maximum value. If P4 V4 is the maximum value, it means that this process showing the temperature also having the higher value. Yes or no? It means this option is correct and this is wrong. This is wrong. If you have any doubt in this, please let me know. So this is how we can understand it, that the the extreme upper isotherm having the higher temperature. This is the correct. I hope that there is no issue. I hope that there is no issue, right? Okay, one process is also there, and what is the, you can say, what we can figure out? Please let me know. Please let me know what we can figure out from this, right? Let's suppose I have this kind of process. This line. Okay, I think I should draw this line straight. Let's suppose that this is line, right? This is the process C, and let's suppose it is my D. Okay, so this is the line of what? This is the line of T2, and it is touched at this. This is the line of T3. T3 is greater than T2. So first my process going from T2 to T3, it means temperature is increased. After the T3, it is going to towards the T2, and T2 is less than, it means temperature will decrease. So from C to D, I can say from C to D, my temperature, first my temperature will increase, and after that it will decrease. After that it will decrease. So this is how we can do the temperature estimation, right? Okay, in the question format, this kind of question can be asked, that let's suppose you have a PV diagram. This is the PV, and there is a cyclic process on the PV diagram. Okay, this is the cyclic process on the PV diagram, right? It is my A, it is my B, it is my C, and it is my D, right? And clockwise process is there. Okay, it is clear to you. So this is my cyclic process, and question is which process having the higher temperature? Which process is having the higher temperature, right? So for that, what we will do, we will try to plot the isotherm. So there are lots of isotherm like that, right? One isotherm which is touched to the BC process. One isotherm that is touched to the BC isotherm, right? There is one isotherm like this, there is this, and there is one isotherm which is touched the BC. And as we know that the isotherm which is farthest from the origin having the higher temperature, having the higher temperature among all the isotherm, right? So we can say the BC process having the maximum temperature. If is there any hurdle in this to understand this, please let me know. तब तक मैं पानी पी लेता हूं, जल्दी से इसको प्लॉट कीजिए एंड टेल मी अगर कोई परेशानी है तो. Yes. Which one? Which one? You want me to explain what? This example or this whole thing? You want me to explain this whole thing or this example? Only this example or all? Cyclic process. Okay. Okay. CD temperature will. Okay, ठीक है. Okay. It means that I should explain the complete concept. See, what I'm saying that this is PV, and whatever these are the diagrams, these are called isotherms. Okay. And for the isothermal process, we all know that these are the isotherms, and these are at the different temperature. Yeah, temperature for one isotherm is constant. Let's suppose this isotherm has a T1 temperature, this is T2 temperature, this is T3 temperature, like that, right? Done. And also that temperature at this, at every point, temperature is T1, right? Same, that temperature at this isotherm will be T2 everywhere. Okay. If I will talk about the CD, so this kind of line was CD. So this is my, let's suppose, C point, and let's suppose this is my D point. And our process is from C to D. So this is C to D. So from C to this, so this line first touched to the T2 isotherm, and we know that T2 T3 relation. T3 is greater than T2, yes or no? Okay. So from C to this middle one, this isotherm, this line is firstly touched to the T2 temperature. After that, it touched to the T3 temperature. It means the process has the temperature firstly the temperature will be T2, and after that the temperature will be T3. And because T3 is greater than T2, it means I can say from this to this temperature is increasing. Okay, after that, after this point, this line touched to the T2 isotherm. So again the temperature is going from T3 to T2. It means temperature will decrease, right? So I can say that from C to D, what is the profile of the temperature? First it is increase, and after that it will decrease. After that it will decrease. Done? Okay, now what about the cyclic process? What about the cyclic process? It is P and B. What is the cyclic process? See, this is this kind of process we have, right? And this is my A, this is my B, and this is my C, and this is my D. And I have to tell that which process has the higher temperature. Which process has the higher temperature, right? So how to measure this? This we will measure through the concept which we discussed, right? Means through the isotherm we will estimate the temperature of the process. It is clear to you? This is my PV diagram. This is my PV diagram, and this is my cyclic process. And they will ask us to what is the which process has the highest temperature. So we will estimate the temperature through the isotherm, right? So in the isotherm, the very simple statement if I can pick, that the isotherm which is farthest from the origin has a higher temperature, like this one. So as we can say directly, now we can say directly that this isotherm has the higher temperature. It is clear to you, yes or no? And this isotherm has the lowest temperature. So in the similar way, the BC process has the higher temperature. Yes or no? If I will write or plot the isotherm, then this kind of isotherm I will get. So this is the, you can say the extreme, or you can say the farthest from the origin, yes or no? So this isotherm has the highest temperature. It is clear to you? It is clear to you, yes or no? So the process which cut this isotherm has the maximum temperature among all the processes. Among all the processes, right? Okay, great, good. So I hope you got this concept, right? Okay, now please put the heading isobaric process. Please put the heading isobaric process. Please put the heading isobaric process. So we have discussed the isothermal, okay, adiabatic process, right? Let's discuss the isobaric process. So as its name suggested, isobaric process means the constant temperature process, guys. Yes or no? Isobaric process means the constant temperature process. It is clear to you? Yes or no? So let's suppose this is, we have the system. This is my cylinder piston system, and these are the variables P, V and T, right? Let's give heat to this system and let's see how this system will behave. How this system will behave. Let's try to understand it. Okay, so as you can see that Q amount of heat I give to this system, and the piston will move in the forward direction, or you can see the upward direction, means work is basically done by the system. Work is done by the system. It is clear to you? So as piston move in the upward direction, so the expansion of the gas will happen. Yes or no? So in the, due to the expansion, the pressure will decrease. Yes or no? See, please see this animation. Now this is the pressure. This is the pressure, and what we are saying, that this is the constant pressure process. It means P will basically going to be constant, and in the expansion process, volume is going to increase, and here temperature is also going to increase. Yes or no? It is clear to you or not? Right? So pressure is basically constant. So guys, if pressure is constant, then if I'll write PV is equal to nRT, and pressure is constant. If my pressure is constant, then can I say that V divided by T is equal to nR by P. nR itself constant, P is also constant. It means I can say that V by T is my constant. V by T is my constant. Yes or no? Or I can say that V is directly proportional to T. So as we know that in the expansion process, my volume will increase. If my volume will increase, then temperature will also increase. Temperature will also increase, right? So let's see this animation again. Expansion will happen. Volume and temperature basically increasing by the same amount, because V is my directly proportional to T. I hope that this is clear to you. Done? Okay. So let's try to draw this, guys. I have this slide or not? Let me see this. Okay. Okay, so let's try to draw this, guys. So PV diagram. What kind of PV diagram we can get, guys? Please, after writing this, put the heading graphs. Put the heading graphs. Put the heading graphs, in which first we discuss the PV graph. First we discuss the PV graph. Okay. Okay. So very simple. For the expansion case, we know that pressure is basically constant, right? And volume will increase. So this is the any state having the parameter P, V1 and T1, and after expansion my pressure will basically constant. So we can see the straight line, horizontal line, and my volume is basically increases. This is my PV diagram, right? This is my expansion. Okay. And for the compression, it is same, that from P, pressure is P, volume is V2, right? And it is going from volume to V to volume V1, right? So that is my arrow will be like this. That's it, nothing else, right? It is clear to you. So this is my PV. This is my PV diagram. This is my PV diagram. Okay. Now we'll try to find out the work done, because we have the PV diagram now. So through the PV diagram we can easily understand the work done. After that we will plot the VT and PT graph also, right? Okay. So what is the work done formula, guys? It is W is equal to integration V1 V2 PdV. This is the process itself. Yes or no? This is the formula. I think it is clear to you or not? This is the formula only. We have you can say discuss it, you can say multiple times. Is it clear to you or not? Okay. So W is equal to, it is my PdV. So it is integration from V2 to V1. I can write it as my P, and final volume is V2, initial volume is V1. Yes or no? So it is my P V2 minus V1. It is clear to you or not? Okay. Okay. Can I write this P V2 minus V1, or you can say P delta V? Can I write this? See guys, can I write this P delta V is equal to NR delta T? Because in the isobaric process pressure is constant, NR is also constant. If there is a change in the volume, you can see the change in the temperature. So P delta V is equal to NR delta T. So with the help of this equation, I can write P V2 minus V1 is nothing but it is NR T2 minus T1. T2 minus T1. Correct? Yes or no? Okay. Okay, now let's try to calculate the internal energy, because temperature is basically changing here. So there should be a change in the internal energy also. Yes or no? If there is change in the temperature, then there should be a change in the internal energy. So change in internal energy is always, guys, it is my NCV delta T. Right? And it is my NCV delta T is my T2 minus T1. This is my change in the internal energy. Okay. If I will talk about the heat transfer, then I have delta U, I have W. I can easily calculate the heat transfer through the first law of thermodynamics. Yes or no? Yes, we can calculate it. So my heat transfer is nothing. My heat transfer is nothing but it is a change in internal energy plus work done. Yes or no? It is clear to you? Let's suppose I am writing this from 1 to 2. So it will be easier for you. It will be easier for you. What is delta U? Delta U is my NCV. Okay. And T2 minus T1 plus NR T2 minus T1. So what is my heat transfer? N T2 minus T1 is my common, and it is my CV plus R. So guys, what is CV plus R? I think CV plus R is nothing but it is CP. So it is my NCP delta T. So very important formula for the isobaric process. So heat transfer in the isobaric process is my what? It is my NCP delta T. See, internal energy is always NCP delta T, but heat transfer is not always NCP delta T. Yes or no? I hope that I am clear with this. Always remember this. Most of the students gets confused in this. So please guys, you can make a note of it, that delta U is always NCV delta T because it comes from the Joule's law. But heat transfer is not always NCP delta T. Okay? Because in the adiabatic process it is 0. Right? And in the different process, Q will be different. So please note down this, and after that we will discuss the further things, right? So my work done formula is my P V2 minus V1, or you can say NR T2 minus T1. So these are the important formulas for the isobaric process. Please tell me, what's your doubt, Muhammad? What is your doubt? Please tell me. Anushka, do you have any doubt? Do you have any doubt, beta? Is mCp delta T and ncp delta T are same? No, Mohammed. mCp delta T is I will explain the heat capacity, don't worry. After all these processes, we will discuss the heat capacity. But yeah, for the timing, just understand it like that. mCp delta T is a heat in terms of mass, and ncp delta T is a heat in terms of number of moles. It is clear to you? So these are not same thing. M stands for mass. So in there, Cp is defined in the joule per kg kind of unit, joule per kg per Kelvin. And in the N, it is joule per mole wala unit will use. So mCp delta T is, you can say, the heat related to the mass, and ncp delta T is the heat related to the number of moles. Both the terms are related to the heat only, right? mCp delta T also represent the heat, and ncp delta T is also represent the heat. But that heat amount is based on the mass, and that heat is amount of, based on the number of moles. Okay. Okay. So as we know that W is equal to P V2 minus V1. So V2 is greater than V1. So in this case, you can say that my V2 is greater than V1. It means this is the expansion process. It means my work done is positive. If my work done is positive, then I can say work is basically by the system. Work done is basically by the system. And if my V2 is greater than V1, it means that in the case of compression, it is system work done on the system. On the system, right? Okay. Now, again in the graph, we will try to plot P and T and V and T. So, do one thing, just think about it, that what kind of P and T trend will be like, and V and T. So, please ask. Whatever is your doubt, please ask. Don't hesitate. And meanwhile, Anushka, just plot the graph P and T and V and T, and after that, match your graph with my graphs. In the GATE examination, if your main motto is to just qualify the GATE examination, then formula is, you can say, okay, you can remember the formula, you can solve multiple questions, you will qualify. But if your target is to get the 2-digit rank, then without derivation it is not possible. So derivations are very, very important, because through the derivation, basically the concept building process is there. Without derivation, you cannot understand the concept thoroughly, right? And as you know that GATE examination is conducted by the IITs, and they are famous for the concepts. So this examination is not about actually mug up the formulas and doing some 100 and 150 questions. That's it. No, this is the exam where you should be very clear about the concepts, right? And that is only possible through the derivation. Okay. And I think in the classical thermodynamics, I did not derive anything. You can see the big, right? There are these are the very simple mathematical manipulations. That's it. If you will say P delta V is equal to nRT delta V is a derivation, then Muhammad, it's not good. Okay. When we will study the FM, you will see the long derivation there, right? So yeah, derivation is important if you want be in the top 10. or even top 100. You cannot get the top 100 or top 500 even without derivation. Okay, so please match your graph, guys. So P and T, as we know that isobaric process, and we will plot these graph for the expansion process. So P and T, P will be constant in the isobaric process, and in the expansion V will increase. If V will increase, my T will increase. It means that a straight line we will see, or you can see the horizontal line, and the pressure at this point is also P, the pressure at this point is also V, and the temperature is T1 and T2, and T2 will be higher as compared to T. What kind of V and T graph we will look like? So V and T is directly proportional, so you will see a straight line graph. You will see a straight line graph, guys. Okay, it is clear to you? It is clear to you? And in this graph, if somebody is interested to calculate the slope of this graph, then the slope of this graph is what? It is NRV. What is the slope of VT graph? Can anybody tell me what is the slope of this PT graph? Bolo. Slope of this graph is NR divided by P. Okay, it is clear to you? So this is all about the isobaric process. Done. So each and everything is important in the isobaric process. Okay, right? Okay. Please write down the next process, isochoric process. Please write down the isochoric process. So we have discussed the adiabatic, isobaric, isothermal. Now we will discuss the isochoric. So isochoric process means constant volume process. Change in the volume will be zero. Change in the volume will be zero. So through the animation we will try to understand this. So again, you can see the cylinder piston arrangement, and these are the PVT properties, right? It is clear to you? It is clear to you? And the piston is, you can say stuck here. The piston is basically, you can say, stopped here with the help of a stopper. Let's see. Means in any case, piston cannot move in the upward direction, right? So let's suppose I'm giving Q hit, guys. I'm giving Q hit. So can this piston move in the upward direction? No, this piston cannot move in the upward direction. So what will happen? What will happen, guys? So the volume throughout will be same. See, this is my initial value of the volume, right? After giving heat, my volume, the value of my volume will be same. So what are the changes? Slowly my pressure will start to build up, because you are giving heat to the system. If you are giving the heat to the system, then my molecules gets energy, and they will, you can say, they will strike to the wall of the cylinder with a very high velocity, right? So in this scenario, my temperature will increase and my pressure will increase. My temperature will increase and my pressure will increase. It is clear to you? It is clear to you, guys? Yes or no? So this kind of processes comes into the category of isochoric. So here you can clearly see that there is no change in the volume. There is no change in the volume, right? So let's try to find out the PV diagram of it. So how to plot the PV diagram? It means that pressure is going to be constant or changing. It's changing. Volume is constant. So by giving heat, pressure is increase or decrease. Pressure will increase. So I think graph will, you will see the graph like this, from P1V to P2V. From P1V to P2V, right? Okay. Yeah. So can we calculate the work done for the PV, for the isochoric process through the PV diagram? Yes, we can calculate this work done. How we calculate this work done, guys? So as we know that this is the work done formula. This is the work done formula. So my work done is equal to integration V1 to V2, and it is PdV. It is clear to you or not? Yes or no? So if I write the formula, then it is my W is equal to P so my W is equal to P V2 minus V1, and as we can see that V1 and V2 values is same. This is V itself. So this difference is 0. That's why my work done will be 0. So in the isochoric process, what is the work done? Work done will be 0. In the isochoric process, what is the work done? Work done is my 0. Work done is my 0. Clear? Okay. Okay, let's plot the next graph. PNT and VNT. PNT and VNT. Okay. Let's find out the PT graph and VT graph. Again, pressure is going to increase and temperature is also going to increase. Yes or no? So what kind of graph you will get? The straight line graph you will get. Straight line graph you will get. Yes, it is clear to you. So these are very simple things. If you have any doubt, you can ask, guys. And what is my slope? It is my NR divided by V. What is my VNT graph? Temperature will temperature will increase and the volume is my constant. So this kind of graph we will get as a VT graph. Right? Okay. What about the heat transfer? Can anybody tell me? What about the heat transfer? If I will write the first law of thermodynamics, then can I say that the heat transfer from Q1 to 2 is equal to change in the internal energy, guys, plus work done from 1 to 2. In the isochoric process, work done is my 0. Then my heat transfer is basically going into the whole heat transfer is going into the change in the internal energy, and we know the value of the internal energy, that is NCV delta T. It is clear to you? So this, what kind of system is this? Very simple, that whatever amount you supplied the heat, that total amount is converted into the, or you can say that whole amount is basically going into the change in the internal energy. So now this Q basically change the temperature. The whole Q amount is going into the change into the internal energy. Or you can say, in other words, I can say that this whole Q amount is basically stored in terms of internal energy of the system. Right? Okay. So this is the work done. This is the heat transfer. This is the internal energy, and these are the graphs. These are the graphs. Done? It's done, guys. Please let me know if you have any problem. Okay. So let's solve a question. So we have discussed so much concepts, right? Now it's turn to calculate the questions based on that. Okay, after these questions we can you can say that we can say that yeah, our concepts are good. So question is saying that, see, what amount of heat must be transferred to the nitrogen at isobaric heating process? So in this question it is saying that the process is isobaric, right? And we have to calculate the what amount of heat basically transferred, and the change in the, you can say, work done, or work done value is given to us. Work done value is basically given to us. It is clear to you? It is clear to you? So what is the formula for the heat transfer? What is the value of the heat transfer in case of isobaric? Can anybody tell me, guys? So it is, we already calculated, it is my Q is equal to nothing but it is my NCP delta T. So I know the formula and I know the delta T, I know the Cp, sir. No, I don't know the Cp also, I don't know the delta T. How can I calculate my heat? How I can calculate my heat? Yes or no? It is clear to you? Right? So how we can calculate this heat, guys? How we calculate this? What is my work done for the isobaric? It is my NR delta T. It is my NR delta T. Yes or no? What is the first law? From Q12 minus the work done is equal to change in internal energy. Change in internal energy. It is clear to you, right? So if I have to calculate Q, then we should have the value of delta U and we should have the value of delta W. So I have the value of the W, but I don't have the value of delta U. So now you can say that how we can calculate this question now. How we can calculate this question now? बोलिए, कोई बता सकता है? कोई बता सकता है? Do one thing. This is my equation number 1 and this is my equation number 2, right? And divide the 1 to 2. It is my Q divided by W is equal to NCP delta T divided by NR delta T. N delta T gets cancelled and it is my Cp divided by R, right? And most of the time you have the value, you will have the value of the Cp for the particular gas. Cp for the nitrogen is 7R by 2. Okay, this value is basically given in the question, right? So, but still you should remember as an engineer what is the value of Cp for the nitrogen at least. Okay, so if I will put the value of the Cp here, then Cp is nothing but it is my 7R by 2 and it is my R. R gets cancelled. I have to calculate Q. Q is equal to 7 by 2 multiplied by W and W is 2. So 2 gets cancelled and 2 unit of the 2 is joule. So what is my Q? My Q is equal to 2 joule here. My Q will be 2 joule here. Right? Sorry, 7 joule. 2 joule तो cancel ही हो गया. Okay. Yes, please tell me if you have any problem. Please tell me if you have any problem. Done? Done with this? Okay. Next. Question is, please this one. Yeah. So question is saying 1 mole of an ideal gas was heated isobarically to delta T is equal to 72 Kelvin. Okay. So question is saying that 1 mole of ideal gas is heated isobarically, so the process is isobaric. Change in the temperature is what? It is my 72 Kelvin. obtains an amount of heat. What is the amount? 1.6 kilojoule. Find the increase in its internal energy and the magnitude of gamma, that is Cp by Cv. Okay, how to calculate? Just give me a thought only. I'll solve for you. Just give me a thought how we can calculate this question. How we can calculate this question. So these are the informations. Number of moles is 1 mole. Change in temperature is my 72 Kelvin. So it is my 72 Kelvin, right? Remember this. And the process is isobaric. The heat exchange is 1.6 kilojoule and process is isobaric. Process is isobaric. Right? Okay. So if the change in the temperature is in, whether it is in degree Celsius or whether it is in the Kelvin, there is, you can say, no problem. There is no problem, right? Okay. So I have to calculate its internal energy, right? I have to calculate its internal energy. I have the value of the Q. If I have the value of the W, then I think I can get the value of, what internal energy, right? It is clear to you, because the you can say with the help of the first law of thermodynamics, you can calculate this value directly. What is the thermodynamics first law? Q minus W is equal to change in the internal energy, right or not? Yes or no? Increase in internal energy means that it is interested to calculate the change in the internal energy. We have Q, yes. We don't have W. So let's try to find out the W. W is equal to, for the isobaric process, it is my nR delta T. I have the N1, I have the R 8.314, right? And it is joule per mole per Kelvin. Multiply by change in temperature is 72. This is the value of W, guys. This is the value of W. And this is basically the value. If I'll write it, it is my 0.6 kilojoule. 0.6 kilojoule. This is my work done. If I'll put this work done in this equation, then what is my delta U? Delta U is equal to Q is my 1.6 kilojoule minus W is my 0.6 kilojoule. So what is my change in internal energy? It is my 1 kilojoule. This is my internal energy change, guys. It is my internal energy change. Now I think I can get the value of Cp by Cv. Because it is the isobaric process, in the internal energy there is a Cv term, and in the Q there is a Cp term. Yes or no? So if I divide Q divided by delta U, so Q is my NCP delta T and delta U is my NCV delta T. N delta T, so it is my Cp by Cv. So Cp by Cv is equal to Q. I know the Q, that is my 1.6. It is kilojoule divided by delta U. Delta is my 1 kilojoule. Kilojoule gets cancelled. What is this ratio, guys? This ratio is my 1.6. This ratio is my 1.6. So this is my right answer. This is my, yeah. Please tell me that this thing is clear to you. But again, I'm saying, if you will basically commit mistake here. Please note this down, that Q is equal to NCP delta T is only for isobaric. I know that you will forget this part. That's why I make this note. Okay, because it is isobaric process, I'm able to write this. Otherwise, I am not able to write Q is equal to NCP delta T. Question is clear? Question is clear? Question is clear? Question is clear? Okay, please read this question. A very good question. There's a, you can say that if you are clear with each and everything, then only you can solve this question. Otherwise, you cannot solve this question. So please read this question. Okay, so please pay attention here, guys. Very good question. Please pay attention. See, this question has a solution of only 3 lines, but you can solve this question only if you have that much clarity about the concept. So that's why I always say, please guys, revise all the concepts if you want to achieve something. Otherwise you cannot achieve anything. See, so we will solve this graph. We will solve this question with the help of PV graph. What is this process? This process is, you can say, isobarically. It means there is a discussion of volume and the pressure. That's why I plot the PV diagram. Question is saying 2 moles of the ideal gas. Please pay attention here, guys. N is equal to 2 moles. And the initial temperature is 300 Kelvin. So let's suppose the process is here, and here my temperature is 300 Kelvin. Right? It is cooled isochorically. It means cooled isochorically means that temperature will decrease and volume will be constant. So if the volume will be constant, then if volume will be constant, it means then I have to go like this. Yes or no? You can say in this line my volume will be constant. It is clear to you or not? It is clear to you or not? Yes or no? Again, PV is equal to nRT. Isochorically means volume is constant and nR is also constant. So for isochoric process, my P is directly proportional to T. Right? There may be a doubt that, sir, if you move in the downward direction by keeping volume constant, if I'll go in the upward direction, then also volume will be constant. Then why I will go the downward direction? That's why I explain this. So P is directly proportional to T. So in the question, it is given that it is cooled. Cooling means decrease the temperature. So if you will decrease the temperature, pressure should decrease. That's why I go in the downward direction. Okay. So let's suppose at this temperature, at this point, I have some temperature. I don't know what is the temperature. It is saying that its pressure is decreased by 2 times. So let's suppose that here my pressure, if my temperature is T0 here, let's suppose my pressure is P0 here, and at this point my pressure is half times decrease. It means it is my P0 by 2. As we know that P is directly proportional to T, if my P will decrease by 2, then my temperature will also decrease by 2. So if my temperature here is 300 Kelvin, so here it is my 150 Kelvin. Again, the gas is then expanded isobarically. Gas will expand, it means volume will increase, and it is isobarically, it means that my pressure will constant. So it means that I should move in this direction. So as you can see that there is expansion, volume will increase and my pressure will be constant, right? Isobarically, so that in its final state, means you have to, guys, it is saying that you have to expand this gas till the temperature of the state will be equal to its initial one. So the gas is then expanded isobarically so that in its final state its temperature become equal to the initial one. So here what is the temperature? It's equal to its initial temperature, so it is my 300 Kelvin. Here my temperature is 300 Kelvin, right? So let's suppose it is my A, it is my point B, and it is my point C. The question is, find the amount of heat absorbed by the gas in this process. What is the process A to B and B to C? In the whole process, I have to calculate what amount of heat is basically absorbed by the gas. Question is very simple. How to calculate? Apply the first law of thermodynamics. My first law of thermodynamics says that the heat transfer in the process, so let's suppose my process is ABC, is equal to nothing, but it is my change in the internal energy. Change in the internal energy in the process ABC plus the work done in the ABC. I have to calculate the Q amount. I have to calculate the Q amount, right? It is clear to you? Okay. Now, see, let's try to find out the delta U for this. Let's try to find out the delta U for this. So guys, from A, B, C, in the process ABC, my initial temperature is 300 Kelvin and my final temperature is also 300 Kelvin. So from A to C, my change in internal energy is what? It is 0. Why? Because temperature is constant. So my delta U will be 0 here. Right? Or you can say, you can apply the formula NCB delta T. Delta T will be 0, then delta U will be 0. It is clear to you? Okay. Now, if you are able to calculate the work done in the ABC process, then question is solved. So I calculate this work done separately. Work done from A to B plus work done from B to C. This is basically the Q in the process ABC. So let's see the work done in the AB. So A to B, there is an isochoric process. In the isochoric process, my work done will be 0. It is my P delta V and delta V is my 0. Yes or no? It is clear to you. So if you are able to calculate the work done from B to C, then it's easy to find out the QABC. It is clear to you or not? Right? So what is the work done in the BC? BC process is my isobaric process. What is the formula of the work done in the isobaric process? It is my NR delta T. What is N2? What is R? 8.31. Delta T is what? It is from 150 to 300. It means 300 minus 150. It is 150. Right? So this is the basically calculation. You can do this calculation and you will get your answer. It is 2.5 kilojoule will be your answer. I hope you understood the problem. I hope you understood the problem. Okay. Is this okay, guys? Yes, Muhammad, please tell me that this problem is clear to you or not. Please attempt these problems at your home also. Take it all these problems like a homework, right? And solve these problems after the class. Okay, these problems are seems very easy when other person is solved these problems, right? When we solve these problems, then you can say then the real hurdle we can feel. So please revise all the concepts, revise all the minute you can say the concepts, minute details, right? Okay, so this is it from my side for the today's class, guys. I hope you enjoyed the class, you learned the new things, right? And again I'm saying, please revise all the things after this class. Just you can say give only half an hour to revise all the things, because after the class it is hardly takes half hour. Okay, so yeah, that's it from my side. Let's meet in the next class. Actually, there's a function. Uh, there's a function nearby my quarter. So there can be a very, you can say, the noise outside if we will schedule this class in the evening slot. So I will try to schedule this class in the afternoon, right? So that we can do our class, you can say, without any disturbance. You can say the disturbance, right? Okay. So because agar function chalega, so there may be a lot of disturbances and we cannot do the proper class. So I will try to schedule this class in the afternoon. So be prepared for that. And thank you so much. Bye bye and take care. Let's meet in the next class. Bye bye, guys.